Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is SHAKIRIN with HARUN from the session 05 Group 15 for the second year Electronic Design Lab SEAE 2742 Semester 1 Session 2023-2024. So today we are going to discuss more about the Digital Electronic Laboratory for the Lab 3 Traffic Light Controller Design Version 02. So as you can see here, this is our specification that we already discussed in lab 2. And then this is our, and also we need to see for the state diagram. And here we can see the net state equation and then the output which we already make it in pre-lab 3. So this is our pre-lab 3. This is the net state equation. Let's just recall a bit about this net state equation. We have the S0 plus, which is the net state for the S0, equals to TS5, which is the transition of the state 5, plus with the transition bar as for the state 0. In our lab, we are using only transition T and T bar. And also next is our output equation, which is S0 is equal to NF plus NL plus SF plus SL. So let's recall that NF is north forward, NL is north left, SF is south forward, SL is south left, and also WF is west forward, and also EF is the east forward. So let's see for our task in lab 3, which is this one. Our first task is to create and design a timer. So as you can see here, this is our timer. The design is we take the design, the actual design from the in lab 1, which is we already make it in week 1. So as you can see, we have 74192, which we use in lab 1 task 2 to count down from 9 to 0. Oh sorry, we have the input here, which is the PL, the parallel load input, and also clock. The connection is according to the inlet 1. Next is the 7447, which are connected to the 7 segment here, so we can display our output, which is the 9 until 0. And also we have here, this is the NOR gate are connected to the TCO, which is the terminal count output. So and also we have our output here, which is the count 3 until 0, which is this one and this one and also this one. This will be our LED after this. And next for the task 2, we have control. We need to design controller. For this controller, we are taking this as our reference. This equation, net state equation and output equation. So remember, net state equation like this: S0 plus equals to TS5 plus T bar S0. We have here our T, which is our transition, and we will flow until the end here. And then we also have T bar, which is the T input is connected to the NOT gate, which make it into T bar. So as you can see here, this is our next state equation. We have here, we recall, so this is our equation, TS5 plus T bar S0. So here we have T with the S5 connected with the AND gate, and also we have T bar with the S0 connected to the AND gate, which we will plus it. We are using OR gate. For the second example, maybe we can take this one, or maybe we could take furthermore like this one. We will be our equation like this. Is S4 plus, which is the next step for S4. We have T times with S3, and then we have T bar times with S4, and I will sum it, and we are using OR gate here. Next, it will be connected to our register we are using here is the D flip-flop. The function of the D flip-flop will choose either input 1 or 0 until to the next output, which is our state. Which is here is state 0, and also same as others. So as we remember, for our output equation, S0 we will have NF. So for example, we have NF, we have NF equals to S0 plus with the others with NF in it, like this one, which is will have something like NF equals to maybe this one S0. Sorry for the handwriting. And next we have NF in S4. And also we have NF in S5. So our equation maybe we will have our input here S0 not get with will be something like this plus, so we are using OR gate. So maybe this is S0, S4 and S5. And we will have our equation output is NF. Okay, something like this. For this is NF, connecting it to the S0. This is connection from the S4 and also connection from the S5. And maybe we can take another example. We have our WF here is only the S. We only have WF, which is the west forward in S2, and also like in S3 we have only east forward. So that's all for our controller. And then we have the integration for both timer and controller for the task tree. Something like this. This is our connection. The controller we connected to VCC. The connection VCD. Here, this is our LED for the count 0 to 3. And our controller here. You can see NF, NL, SR, and so on. And also we have input reset here. So for the timer, we have our waveform like this. This one. So this is our timer waveform. So let's simulate it. See the problem. Study for. We are using quarters prime, so we need to do this correction. Okay, we will have our output something like this. This is for the timer. Yeah, timer. This is before, this is after. And then we will have our this is for the integration. Let us see for the controller first. So this sorry. Oh, sorry, both of this is the integration. Waveform for controller, which is this one. Sorry, yeah, this one. So let us edit this audio form. okay, we will delete it, save, then this will, we will need to repeat the step, maybe not. Okay, good. Okay, or maybe, yeah. So let's just use the controller, let's just compile it so we can make the waveform. Okay, so select the controller, make it to set the stop level entity, then compile it. So for the timer we already compiled it, so that's why the waveform is already that much. Okay, then we will create the waveform using University Programming Language app. Set the not this. Okay, we'll arrange it first. So we have T here. We arrange it so that we can see it better, rather than seeing it in not looking in good order. So NF is up here, EF is down here, swag is here, NF, NL, NR, SF, SL, star, F, EF. So for our clock, we usually do high or low, high, low, until the end. Here, 840, 40. And then for reset, usually we just take for the first one. I think our high will be like this, only this one, and the rest will be 0. So if we reset it, so our output then will be inverted from itself, from the user one. Maybe we have our output is 1, but our reset is 1, so maybe we get our output is 0. So for the T, we will follow the clock. The transition will follow the clock. Okay. So for the first prime, we need to delete this. Okay. We need to this. So save your folder for maybe this is for the timer. Okay. Again. Okay. Oh, sorry, this is for the not the waveform timer. This is for controller. We got something like this. So S0 is on. So our NF, we will got NF, NL, SF, and SL. When we got our S1 is high, and then we will got SF, SL, star. Then for the S2, we will got only WF. For S3, only EF. And then for S4, it's the same as S0, which is NF, NL, SF, SL. And then for the last one, S5, high, we will get NF, NL, and NR. And the cycle will continue. So that's for the controller. Let's see for the integration. How about we for the integration, we will compile it, so we will not encounter any error again like for the controller. So compile first. waveform. So insert all the input and output. Okay, then we arrange it. Not reset. Not reset is the count here. EF will be down here. So for clock, as usual, we will go up and high and low. So maybe you can take the period 10 milliseconds. For reset, as usual, only for the first one. This one. Then for our BCD is the count up. Or maybe we can also all of it. We will have our output here. So maybe we run it. Change something like this. So this is for the integration. Study default and normal PT. This animation. I hope it will be good. Okay, we got it. As you can see, this is so our VCD will be something like this. So we will show what is this. And then we will so for the count with the LED here will be light up according to the output here, NF, NL, NR, SF, SL, SR, WF, and EF. So I think that's all for the Lab 3 Digital Electronic Design. I hope this release will be benefit to all of you. So thank you.